Next thing I will do is to load a machine, and then we will customize that, create a MCF file from scratch. As a machine I will not create a new one, I will take sim8, which is a table Hermle machine, and to have a test part I've just created a box that I will use as a blank for the machine. So for the blank I will use the template concept to create a new chem part. I've selected the blank as a part reference. Loading that. So now I have the part in the chem setup. I will then go to the machine tool view, make a replace machine, retrieve a machine from the library, select sim08 with the numeric controller and millimeter. So as an example I will take the numeric 840D, since the 840D is a pretty powerful controller and it allows me to really show all the concepts that we support with CSE. And if you've mastered the 840D, then you can basically apply the same methods to Heidenhain or Fanuc or all the other controllers, since the numeric really supports all the functionality that a modern controller can handle. So I will select sim08, numeric. Now loads the machine, and now I can position it. I will use a part mount junction for that and create a new one. I want my part to be set up in the middle of the machine, so I will place the part mount junction in the middle of the part with Z-axis up, so that it should really be positioned in the middle of the machine. Yeah, that's what I would like to have. The next thing I will do, just to be prepared, is to add the part into the part group. Select it, select the object and click OK. That's it. Then I can save the file. I will save as, call it deep 030 chem part. Okay, so that's it. Now I've created my chem part that references the machine. The next thing I will do is, at the moment of course sim08 still has a reference or has MCF and CCF files, so if I would start the simulation it would of course run, but I want to show you how to create a new one. So that's why I try to locate the machine. It's on the machine, installed machines, sim08, CSE driver, numeric. I will create me a backup folder so that I can restore it later on, and I will copy the CCF, the MCF and also the ini file into this backup folder. Actually I can copy the whole subprogram folder into the backup folder. I don't need that at the moment. So now I really have an empty configuration. I can test that if I go to simulate machine code file. I have to create a text file, test program.txt, and simulate that. I should get an error message that he cannot locate the controller configuration file. Okay, so I've verified that. So the next thing I will do is to create a new MCF file. For that I will start my machine configurator. Here it is. In machine configurator I said I will create an empty file so that I can show you all the concepts. So that's the reason why I will not use a CCF, library. So I will really create a configuration entirely from scratch. So the first thing I will have to do is to select a controller. So I will pick 840D. The machine name is arbitrary, you can put whatever you want. ISV does not display that, so that's really just to document that in the MCF file what you have. You can call it, for example, test Hermle table. The next time is the cycle time. That's actually the epo takt of the machine, the internal cycle time in milliseconds that the machine is using. That is later on relevant for motion planning. You can just leave the default value. In most cases that should be fine. Motion precision we'll get to later, and also the other parameter you can just leave on the default. What you can also use here in Machine Configurator is a history. So every time you save the file, you can store a new command here. So I can call that the first version of my MCF file. The next section is something that is mandatory. So we need an axis configuration. In this case, I need, with the right mouse click, add axes and spindles. The axes that I add, they need to fit to the axis names that you have configured in the Machine Tool Navigator. So the axis names, I need to use X, Y, Z, S, A, and C as axis names. So that really needs to fit, otherwise the axis will not move. So to add axis, I will select axis, select the axis name. I will just do that for all of them and don't care about the parameters. I will explain that in the next training session. So add an X, Y, and Z axis, an A axis. The A axis I need to select the type, so by default it's going to be linear axis. On the A axis I need to use, or I want to use, rotational. Then I also want the C axis, and the C axis I want to be infinite, so that it can spin infinite times. For the A axis you don't have to add any limit checking, because the limit checking is done based on the limits defined in the kinematic model. So you should really make sure that the limits in the kinematic model are set correct, while in Machine Configurator you can leave those limits on the default. That has been used in relency, and we may make use of those in the future, but at the moment up to NX 7.5 those values are not used. Hard limits and soft limits, so they are not used. So I have the axis, and then I also need one spindle. Spindle is a special type of axis, so that's why there's a special axis type, and it appears in a different section. Like I said, the parameters, the remaining parameters for feeds and speeds, I will tell you how to feed those with correct values in the next session. The next thing I will have to do is to add a channel and give it a name. So I add a channel with right mouse click, add channel. And then you can specify a name. The name is actually arbitrary. Also ISV does not display this anywhere, so you can type whatever you want. On single channel machines I typically use main. On multi-channel machines it's recommended to use the channel number, so to call them 1 and 2 and 3. That makes your life easier if you also call the axis X1 and X2. But we will see that later on if we come to multi-function machines, multi-channel machines. So now I have the channel. What you can do next is to create a default configuration that tells CSE which axis belongs to which channel upon initialization. So that's really just if you load up ISV and initialize CSE, which axis does belong to which channel. On a single channel machine that's of course easy. You can add all axes and also add all spindles. Machine Configurator automatically fills out the main spindle and the geo axis. What this is used for we will see in later chapters. So that's as a basic configuration, that's good enough. At the moment all the commands and methods and so on will be entirely empty, but as a first step to initialize correctly, this should be good enough. So I will now save this file, click Save As. Then I have to locate the folder. That should be under C, Program Files, UGS, Resource, Library, Machine, Installed Machine, Simo8, CSE driver, C numeric. Be sure that you use the correct name. To make my life easier, I will use the name of the previous file and then just go one level up. The machine configurator stores this name, and I'm sure that it's named correctly. Another remark: for NX 7 and NX 7.5, you should select the latest version. That's machine configuration file version 2.0. For NX 6, you need to use machine configurator file version 1.0. The difference is, in version 6 we did not yet support the encryption capabilities or the different protection mechanisms of CSE. With version 2.0, so starting with NX 7, we changed the encryption scheme, and that allows us to use the advanced protection mechanisms of machine configurator that I will talk about in a future session. So I will select format version 2.0. I have the correct name, and I will just save it. I can minimize machine configurator, and the next thing I can do is to go to Tools, Simulate Machine Code File, use my empty test program again, but in this case I don't get an error message anymore. ISV dialog comes up, and in the details window that you can open, you can see that my MCF file was processed successfully, and that my test program is in use. Of course, simulation will not do anything since my test program is empty, and if it would not be empty, you will get error messages. But that at least proves that my MCF file is working correct and that CSE can initialize based on that.